In this video, we're going to be looking at the inverse of a straight line, right? We know that a straight line is a one-to-one function. So the inverse of a straight line can be written in a function notation, because it is also going to be a one-to-one function. Okay, perfect. So they say determine the inverse function of p of x and sketch the graphs of p of x and the inverse of p on the same system of axes. Okay, so let's do that, ladies and gents. Okay, I need this. Okay, sharp. So to do the inverse function, right, remember we have p of x equals to negative 3x plus 1. We're firstly going to switch x and y. Né? We're going to switch. So the first thing, you switch, x becomes y, y becomes x. Né? So remember, this guy here is y. So basically, whatever was there, you put x now. Is equals to minus 3. Wherever there was x, you put y, then plus 1. Okay. And then after switching, you need to write it in terms of x. So y must be the subject of the formula. So, okay, I see that, okay? Okay, let me write it this way, actually. 3y plus 1 equals to x. I didn't change everything. This part is still there. This part is still there. Perfect. I just switched my left and made it my right, and my right made it my left. That doesn't affect the equation. Perfect. So we need to make y the subject of the formula. So I have minus 3y equals to x. The 1 goes that side to become a minus 1. And then I'm going to divide everything by negative 3, by negative 3, divided by negative 3. Then we can all see that, okay, therefore, my inverse function will be y equals to, here I'm going to have, remember there's an inversible 1, so I have negative 1 over 3x. This negative and that one will become positive, so I have 1 over 3 there. And then, because the inverse is also a function, it can be written in function notation, which is p minus 1x. It's negative 1 over 3x plus 1 over 3. If the inverse was not a function, remember, we cannot write it as a function notation. We are just going to leave it as y equals to, then that's it. Né? Perfect. So now I have my inverse and my function. And then they also want us to sketch the graphs. Né? They want us to sketch there. Okay. So to sketch, ladies and gents, né? It's very simple. If you have the sketch of the first one, you have the sketch of the second one. I'll show you now. Let's say p of x here. And then we have that there. Sharp. Let us do, remember p of x is y equals to minus 3x plus 1, right? Let's do the x-intercept here. Remember, x-int, you make y 0, right? So this guy here will be 0 equals to minus 3x plus 1. Then I take it that side, which is negative 1 equals to minus 3x. And then I need to divide all the sides by minus 3 so that the x is by itself. Therefore, we can see that therefore x is 1 over 3, right? Which is basically, I think it's 0.33. Né? Remember, you only write in decimal if you need to sketch. Né? But if they just needed the x-intercept, just write it in this form. So the x-intercept is 1 over 3, coordinate 0. But you're just going to use the decimal point for sketching, né? The approximation. That's the only time you use the in function or you use decimals. Né? The only time is when you want to sketch. Otherwise, always take it to common fraction. We need exact values for any other thing except for sketches, because sketches are approximations. Okay, now on this graph here, this was x-int. Then let's get the y-int. It's easy, right? It's always this number here. So your y-intercept is 1, and then remember for y-intercept we make x 0. So that's your y-intercept. Né? Perfect. And then, ladies and gents, this is easy now to get the coordinates on the inverse. You don't need to do calculations using that. You're going to say, therefore, you can see that, okay, you're going to switch this guy. Ne? The 0 will come here, the 1/3 will come this side. So you have 0 is to 1/3. And you're going to have 1 is to 0 because you're going to switch these ones as well. Do you see it? When you invert it. Perfect. So you agree that the x-intercept of the function becomes the y-intercept of the inverse. Ne? Oh, I forgot to put -1 there. And the y-intercept of the function becomes the x-intercept on the inverse, just like here. This is now y-intercept. It was x there. It becomes y here. This was y there. It's going to become x int here. The reason because we reflect across line y equals to x. And then you need to remember that this is 0.33 when you sketch. Ne? So to save time, I just showed the sketches. Here I drew them with Desmos graphene. Perfect. So let's see. Which one is g? The red one should be g of x because it's passing through +1. Yes. So that is p. That is our p of x. Ne? I mean. So I firstly, you firstly plot the y-intercept. Remember, this graph is p of x. Ne? Then this one will be p inverse of x. Okay. Sharp. And then you plot the x-intercept of that, and then you join the two. Ne? Always show arrows to show that it keeps on going up and down. Then this one is going to be 1 and 0 now. It becomes there. This one is going to be 0 and 3, 3, 3, which goes there. Then you join them as well. Oh, ladies and gents, I made a mistake. Sorry about that. This is not our p of x. Our p inverse x will be this one. Yeah? This line, okay, I'll show arrows at the end of it. It's what we call line y equals to x. Ne? And because I was using a graphing calculator, I couldn't show it properly. Ne? You not draw solid line, you always use dotted lines for this line. Ne? Always when you draw the graph and its inverse on the same set of axes, you always need to show the axis of symmetry. This is the mirror image. If you check, this side is exactly the same as that side. That's why we call it the axis of symmetry line. And the last thing I need us to discuss here is domain and range. Domain, range, right? Domain and range for both this p of x and its inverse are going to be the same. Eh? Domain is x elements real, range is y elements real. Any straight line will have x element real as the domain and y element real as the range. And that's it about this video, ladies and gents. Please don't forget to subscribe and share with family and friends. Aluta continua. Tango.